Hello. So modern spatial positioning is moving away from infrastructure-based solutions that are really inflexible and expensive to systems that can automatically learn maps based on sensor data and at the same time simultaneously locate within those evolving maps. It's a technique that's called SLAM, and it's well known in the robotics and automotive industry. Now, for safety critical applications, no one single sensor is reliable enough. So typically these solutions will have multiple sensors to get the maximum amount of reliability. An autonomous vehicle in development today might have a dozen sensors, for example, cameras, LiDAR, radar, and so on. What you might not realize, you might find surprising, is actually that the ground surface over which a vehicle travels, so for example, that might be the track bed if it's a train, or it might be the road for a car, it actually contains a huge amount of information that can be used for localization that's completely underutilized today. So that ground surface, it has structure, and that structure is different at different places. That's how it's done. And actually, although the ground does change, it changes generally quite gradually, and that change can be learned as well from observations. So we've developed an absolutely unique localization platform that uses a downward-facing camera to measure and map the ground surface below moving vehicles, and then to use that map like a fingerprint to work out exactly where the vehicle is. And those maps are all created automatically from the sensors, and as the ground changes, the maps are automatically updated. So it's quite hard to make this work, and the reason why is because the ground surface below a vehicle actually moves very, very quickly. So if you use normal cameras, that just blurs out entirely. And if you use high-speed cameras, you end up generating lots and lots of data that is very difficult to process in real time efficiently. So we use a very novel type of image sensor based on biological vision called an event camera. Now, an event camera measures visual change rather than measuring image intensity. And that means that although it produces orders of magnitude less data, it can still produce data with very, very fast response times. So we've been developing this technology for about 18 months, and we've just completed a proof of concept with Deutsche Bahn, which I'm going to tell you about. It was very successful. So our objective was to position this train up to 200 kilometers an hour within 10 centimeters precision. So we built a proof of concept sensor, which was then installed onto the train, and then we used this to build map data, and you'll see in a second what the event camera output looks like. And we use this and machine learning to build a map. And here, this is a 400-meter fingerprint of a map section. And we can simply take live camera data coming off the event camera from a train and match it to our maps using, again, robotics and AI techniques to really pinpoint that train. We were getting 2-centimeter precision using a very, very simple system. You'll see on here, we've also plotted GPS coordinates measured on the same test run. And GPS, even though this is quite an open space, is very, very poor precision. Okay. So overall, this was a very successful project. And we're now developing our first product. Thank you.